Hi, my name is Abhishek from Institute of Aeronautical Engineering. My roll number is 2095182102. I want to explain about physics. In physics, the topic name is calculation of work done by the spring force. Spring force. Actually, spring force is given by the expression F equal to minus kx. If suppose this is a spring, the length equal to L and the distance between length in middle x and the point O, where k is a spring constant measured experimentally for a particular spring. The value of k equal to minus f by x if you transpose measures the stiffness of the string. Have I value indicates that we would require to apply greater force to change the length of the spring. This relationship defining spring force is also known as Hooke's law, which is valid under two specific conditions. One is the mass of the spring is negligible and can be neglected. There is no dissipative force like friction involved with string. The attribute x is measured from the position of the neutral length or relaxed length, the length of the spring corresponding to situation when spring is neither stretched nor compressed. We shall identify this position as origin of coordinate reference. The negative sign in the expression indicates an important aspect of the nature of spring force, that it always opposite to the direction of the displacement. It means that it's always directed towards the position at neutral length, that is origin. See the figure to visualize how spring is always directed towards origin. See in this figure, spring force is always directed towards origin only, where the O is there, the X, the force acting. Context of spring force. The force is on the body, means block, attached to a horizontal spring may include friction. If the surface is between block and the surface is rough, for the sake of simplicity, however, we shall consider the surface to be smooth. The force due to the gravity and normal force are normal to the motion and do not influence force analysis here. As such, we will not consider either friction or gravity while calculating work for the motion on smooth horizontal force. Just like the case of gravity, there are two situations with respect to applications of force on your body by this spring. 1. In one case, the body is given a jerk, say towards right, and the body lets go. In this case, the only force in the block is spring force. The situation is similar to vertical projection of an object with an initial speed. This case of spring force therefore is specified by an initial speed, preferably at the origin as shown in the figure. See, in this figure, only force on the block is spring force, other than not there. In other case, there is external force S in addition to spring force. The horizontal force is continuously applied on the block as it moves along the surface. The situation is similar to the case of pulling a lift vertically by string and pulley arrangement. In this case, we may be required to analyze external force with the help of a free body diagram. There is other force tension T besides spring force. In this figure, you can easily understand. Work by spring force. This is the main topic. Now we are set to obtain an expression for the work done by the spring. We give the block a jerk to the right as discussed earlier. Let the extension of the spring be x. Then F equal to minus kx. As the force is variable, we cannot use the expression F or cos theta to determine work. It is valid for constant force only. We need to apply expression involving integration to determination work. We apply the integration work F equal to W is equal to integration f of x dx. Let x1 and xf xn and xf be the initial and final position as we know of the block with respect to the origin. Then W is equal to integration from initial to final positions, integration minus kx dx. W is equal to, while we transporting minus k x square by 2 integration to W is equal to 1 by 2 x square minus x square If block at origin is then xi equal to 0, our initial position is 0 and xi equal to xa, then w is equal to 1 by 2. Substitute in xi and xf values, we get 1 by 2 kx square. When block is subjected to the single force due to spring, the work is given by above expressions. During motion towards right, the spring force on the block acts opposite to the direction of motion. Its magnitude increases with increasing displacement. Thus, spring force does negative work transferring energy from the block. As a consequence, kinetic energy of the block decreases in speed, that the speed decreases. This process continues till the velocity and kinetic energy of the block are zero. Spring force then pulls the blocks toward the mean position, that is origin, in the negative x direction. The spring force now is in the direction of motion. It does the positive work on the block, transferring energy to the block. The process continues till the particle returns to the initial position when its velocity is same as that in the beginning, as there is no dissipative force like friction. Kinetic energy of block on return, as it may know that origin is equal to the beginning, kf equal to ki. For this round trip, net work by spring force is 0. Net transfer of energy to or from the particle is 0. Suppose I do a problem. A block of 1 kg is attached to the spring and is placed horizontally with one end fixed. If spring constant is 500 Newton by meter, find the work done by the horizontal force to pull the spring slowly through an extension of 10 centimeters. Yeah, so we have to go to solution. So it is not explicitly stated, but it can be inferred from the word slowly that the block is pulled without any kinetic energy. This is a situation when initial and final speeds are zero. This means that initial and final kinetic energies are zero. It's equal. Hence, work done by the two forces is zero. In this condition, work done by the horizontal force is equal to the work done by the spring force. This is the main point, but opposite in sign. Now, work done by spring is from the form of W is equal to minus 1 by 2. Take spring constant, and we have 10 centimeters that we can convert into 0.1 square by calculating W is equal to minus 2.5 by J. Thus, work done by the horizontal forces W is equal to 2.5 joules. We must note this situation is exactly similar to that gravity. In order to find the work done by any other external force, we calculate work by spring force. In this nutshell, we measure the work by other external force indirectly using a known work by spring force.